What is propagation constant in transmission lines? Imagine sending a message across a wire or cable and wondering how the signal changes as it travels. That's where the idea of the propagation constant comes into play. It helps us understand how signals behave along transmission lines used in power systems and renewable energy setups. The propagation constant is a number that tells us how an electromagnetic wave changes as it moves through a transmission line. It combines two key effects: how much the signal gets weaker and how its phase shifts. This number is written as gamma or gamma, and it's a complex number. Think of it as having two parts, one real and one imaginary. The real part, called the attenuation constant, shows how quickly the signal's strength drops as it travels. This loss can happen because of resistance in the wire or energy absorbed by the insulating material. It's measured in Nepers per meter, which is a way to quantify how much the signal diminishes over a certain distance. The imaginary part, called the phase constant, indicates how fast the wave's phase changes along the line. It tells us how many radians the wave shifts per meter. This phase change affects how the voltage and current waves line up at different points along the line. The phase constant relates to the wavelength of the signal by the formula beta equals 2 times pi divided by lambda, where lambda is the wavelength. Putting it all together, the propagation constant is written as gamma equals alpha plus j beta, where alpha is the attenuation constant and beta is the phase constant. The letter J is just the imaginary unit, used in math to representing a 90-degree phase shift. In power systems and renewable energy projects, understanding the propagation constant helps engineers design lines that deliver power efficiently. It shows how signals weaken and shift phase, which is essential for controlling power flow and reducing energy losses. To find the propagation constant, engineers use the primary line parameters: the series impedance, which includes resistance and inductance, and the shunt admittance, which includes conductance and capacitance. The formula gamma equals the square root of the product of the impedance and admittance links the physical properties of the line to how signals behave. Knowing the propagation constant allows engineers to predict how voltage and current waves will move along the line. This helps in designing transmission systems that keep signals strong and stable, minimizing energy loss and phase issues. It's a vital part of ensuring reliable power delivery from generation sources to homes and industries, especially as renewable energy sources become more common.